Good day, students. Welcome to mathgoodserve.com. In this clip, we're going to be going over problems 16 to 19 of the Florida Algebra 1 and, of course, computer-based practice test. All right, let's take a look at question number 16. So Florida has 67 counties. Texas has 254. Some relevant information concerning Florida and Texas are provided. The mean, standard deviation, and median for Florida is provided. Likewise, Texas. And then this is the situation. A business moves its corporate location from Texas to Florida. As a result of the move, 8,193 people moved from the largest Texas county to the smallest Florida county in terms of population. Select all the population statistics that will be affected by this population change. And then if you take a look at this stats right here, you have the smallest, first quartile, median, third quartile, largest for Florida and Texas. So what impact does this move have on these statistics that are provided here, and also these statistical measures downstairs here too? Okay, before we go ahead and solve the problem, I wanted to just give you a visual as to what's going on, okay? So in the case of Florida, we had 8,000 people moved into where? We had 8,193 people move into the smallest county in Florida, okay? So just focus your attention on the stats, the one in green. So let's assume that this is the statistical situation for Florida before, okay? But what happened is that more people were added to the smallest, or we can call it the minimum county in Florida, okay? The county with the smallest population. Now, what happens when you add numbers to a particular county? Does it increase or does it decrease? It increases, right? So the result is that there is a shift in the minimum, okay? It increases, it shifts to the right. You see that shift there? That is because we added 8,000 more to the minimum. Every other thing remains the same, okay? So let's just write down a note here. So Q1, Q1, Q2, Q2 is the median, okay? So keep that in mind. Q2 is the median, Q3 and max are unchanged. That's for Florida, okay? What's changed here mainly is the minimum, okay? Because that's the population was added just to the smallest county. Now, how about Florida? Texas. What happened in the case of Texas? Population was taken out of the biggest county, okay? So what do you think is going to happen to the maximum, the county with the maximum population? Is it going to stay the same, increase, or decrease? It's going to shrink, okay? So the largest county is going to shrink, so that's going to cause the maximum to shift to the left, okay? So the minimum, Q1 and Q2 and Q3 will all remain the same in the case of Texas, but the maximum will shrink. All right, so let's keep that in mind. So let's just write down a side note. The minimum Q1, Q2, and Q3 are unchanged. And don't forget, our median is Q2. Okay, so the first statistical measure we're to compare after the change is the interquartile range for Florida. Okay, so before we do that, let's go over the formula for calculating the interquartile range. So formula for interquartile range, IQR for short, is the third quartile minus the first quartile. Okay, all right, so what happens before and after in this case? Let's go ahead and work it out. So before, so this is IQR for Florida, okay? So before, what is the interquartile range? The interquartile range is Q3 minus Q1, right? So if you look at your stats here, Q3 is for Florida 337, 362. minus 27,000. That's the first quartile is Q1. Okay, so this is Q1 and this is Q3. 27,013. If you subtract with your calculator, you end up with 310, 349. Now, what happens after the move, after the 8,000 plus people moved into the smallest county in Florida? Guess what? The interquartile range is going to be 337,362 minus 27013. Wait a minute, what just happened? These two are exactly the same, okay? Why is that the case? Remember, Q1, Q2, and Q3, including the maximum or the largest, were unchanged for Florida. Only the smallest got changed. So that means that the interquartile range will remain unchanged, okay? So we can just say it stays the same, stays the same. That fact was illustrated in the visual that we provided up here. So when the move happened, more numbers were added to the minimum, so that's why it had a shift. There was an increase in the minimum, but everything else remained the same. So Q3 and Q1, the determiners of the interquartile range, were unchanged. So IQR for Florida stays the same. Okay, next, let's take a look at the mean of Texas. Okay, so for this one, we can calculate the mean of Texas after the change, and then see what happens if it increases or decreases, okay? So let's title this mean of Texas. All right, now, first of all, we need to know the old population or population before, okay? So population before for Texas is simply going to be the mean multiplied by the total number of counties, okay? Number of counties. That's how you calculate the total, okay? Because the total divided by the number of counties give you the mean, so the mean times the number of counties will give you the total population, okay? So the mean is provided is 104,127 multiplied by the total number of counties we have in Texas, which is 254. So that gives us the total population of Texas before the move as 26,448,258. Okay. So what happened? How are we going to figure out the new population? So the new population is going to be new population or after population is going to be before population minus what? Minus that 8,193 that got moved to the smallest county in Florida. Okay, so the before population is 26,448,258 minus 8,193. Okay, when you carry out the computation, you end up with 26,440,065. Okay, so this is a new population for Texas. So what is the new mean? The new mean for Texas. The new mean is simply going to be the population divided by the number of counties. Okay. All right, so the total population is 26,440,065. We divide that by the number of counties, which is 254, which is equal to, if you do that in your calculator, 104,094. Okay, so what does this tell us? The before mean is 104,127, and after mean is 104,094. 0.094. So what do you see here? The mean decreased. Okay, the mean decreased. The mean of Texas decreased. Okay, I hope that makes sense because you're taking out numbers from the total. So you're going to expect the mean to decrease since the number of counties remain unchanged. Okay, so the mean of Texas decreased because of that reduction in population. All right, so we're going to check off the decreases box for the mean of Texas. Now, next we're going to take a look at the median of Florida. Okay, so what I want you to do is recall that the median is equal to Q2. Now for Florida, what did we say concerning Q2? Only the minimum was altered. Okay, so Q2, guess what? Remains unchanged. So the median or Q2 remains unchanged for Florida. Same applies to Texas because only the maximum or the largest was altered in the case of Texas. Okay, and then for the last one, it talks about the standard deviation. Okay, the standard deviation of Texas. So let's take a look at that. So if we look at Texas, one thing you want to note is that the standard deviation is the measure of what? The standard deviation is the spread, okay? The spread of the data from the mean, okay, from the mean, all right? So if you take a look at these two scenarios right here, this mean and then the max, and then this alteration, the deviation is how spread the data is from the mean. Okay, now if you look at this data representation here, does it look like the data points, the spread has been expanded or has it been reduced? You notice that every other point stayed the same, minimum, Q1, Q2, and Q3 stayed the same here, but the maximum was shifted towards the left. Okay, so the spread basically what? The spread decreases because of this reduction in population. Okay, it decreases, so the spread, the deviation away from the mean is smaller in this case because of the reduction of the population of the maximum. Okay, because we're looking at the spread of the entire data set, the deviation from the mean. So because of that reduction of the maximum, we have a reduction in the spread, which means that the standard deviation decreases. Okay, so think about the word deviate. It basically means how you separate or how you distance from the mean. Okay, so those are the answers for question number 16. Okay, so let's go ahead and check in our answers. IQR stays the same because Q1 and Q3 were unchanged. The mean decreased for Texas because the total was reduced, whereas the number of counties stayed the same. The median for Florida stayed the same because only the minimum was shifted to the right by the increment. And the standard deviation, the spread of the data from the mean, decreased in Texas because the maximum was shifted to the left. And then that reduced the spread or deviation of your data set. Okay? All right, let's take a look at question 17. It says the graph shows the number of acres and millions of farmlands in the United States from 1975 to 2008. Okay, so you have this data set right here being graphed. Question, which statement describes the average rate of change of the graph? Okay, so the main question here is, what is the average rate of change? Okay, the average rate of change. So one thing I'd like you to recall is as follows. The average rate of change, is the same thing as a slope. Okay, and what do we know the slope is? Slope is rise over run. or if you want to use the coordinates is y2 minus y1 over x2 minus x1. Okay, so you can use a slope triangle here to determine your slope, or you can use your coordinates to carry out your computation. Okay, so what we want to do, we're going to pick 2 points. Okay, so what we're going to do, we're going to pick two points on the graph that are lattice points. Okay, so basically 2 points on this line that fall on the intersection of the x and y grid. So we can pick this point. This works nicely. And let's see. Okay, this point works too. So the result we're going to get is going to be an estimation. Okay, so you want to be flexible with whatever result you get. It's not going to be exact because this is a data set that's fluctuating. It's not a perfectly straight line. All right, so this coordinate right here is 1975, 1060. So that's the x1, and this is the y1, this one right here. Okay, so y1. Next point here is 1990 and 980. So this is going to be our x2, and this will be our y2 right here. Y2 will be 1980. Okay, so why are we finding x1, y1, and x2, y2? x1, y1, x2, y2. Well, we're looking for the rate of change, which is the slope. Same thing, okay? So let's find the rate of change here, or the slope. R of c, which is equal to y2 minus y1. So y2 is 980 minus y1, which is 1060, divided by, so this is your rise. Okay, if you're drawing a slope triangle, we just calculated the rise. Now I want to calculate a run, which is x2, 1990 minus x1, 1975. So this is your run. Now one thing you notice about this data set is that your rise is negative because the line is decreasing from left to right. So we should expect a negative result. So you can power up your calculators here. Okay, so I'm going to be making use of the calculator that's provided for you on the testing program. So if you click on C calculator here, just click on that, and then this nice little calculator shows up. All right, so let's do y2 minus y1. So y2 is 980 minus y1, which is 1060. Group that in a parenthesis together, okay, divided by, so this is your rise. Your run is x2 1990 minus x1 1975. What was that? And then you get negative 5.3 repeating, okay? So our answer is negative 5.3 repeating. So what does this mean? This means that the acres decreases by 5.3 million each year. Okay? So let's write that down. The acres, or amount of land. So the meaning is meaning of rate of change equals negative 5.3. Is that the amount of land decreases by about 5.3 million acres each year. Okay, so this is just our estimation. Let's take a look at the options and see which one is closest to this, okay? So number of acres in the farmland decreases by 0.2 million each year. No way. It's much more, okay? Option B, the amount of farmland in the US decreases by 4.8 million acres each year. That's close. Let's look at the other options. The time it takes the farmland in the US to decrease to 100, no. Every 5 years, the amount of farmland in the United States decreases by 20 acres. That's absolutely not what we got. So the best answer is option B, because 4.8 is very close to what we got, 5.3 million, and that's the amount of land that it decreases by each year. Remember I told you it's just an estimation because this is not a straight line, it's a fluctuating graph. So our answer was just an estimation. It gave us an idea, a rough idea of the rate at which the amount of land decreases. So 4.8 million should be a much more accurate figure. All right, so our answer for number 17 is option letter B. Okay, let's take a look at number 18. It says a high school drama teacher organizes a musical production. He wants to record the number of students involved in each part of the production. He uses a two-way table to display the data. The drama teacher knows that approximately 55% more girls participate in the production as actors than as stage crew members. Complete a two-way table to show a possible breakdown of the students. Okay, so there are a lot of unknowns in this problem. 1, 2, 3, 4, 5, 6, 6 unknowns. So how do we get started? Well, the clue has to do with the number of girls. We have 55% more girls on actors than as stage crew. So that's what's going to help us to unravel this mystery right here. Okay, so since the number of girls that are actors were dependent on the number of girls that were on the stage crew, by their definition, we're going to use the number of stage crew as the foundation for defining our variables. Okay, so let the number of girls on stage crew be X. Okay, so that's going to be our unknown, X. So if the number of girls on stage crew is X, then that follows that the number of girls that are actors is going to be 55% more. Okay, so what does that mean? 55% more than X. Okay, so if we want to write this in mathematical form, it's simply 1 plus the percentage in decimal form, 5 multiplied by the number of girls on the stage crew, which is X, 1.55X. Okay, all right. What do we know about the total number of girls? Total number of girls is 73. Okay, so total number of girls is 73. All right, so if we add horizontally, number of girls that are actors plus musicians plus stage crew should give you the total number of girls. Okay, so for girls, actors plus musicians plus stage crew, all this together gives you the total number of girls. Okay, all right, so how many actors were there? I put actors, let me see. Oh, actors is 1.55x. Okay, we already figured that earlier. So it's 1.55x is 55% more than the number of girls on the stage crew, which is x. Plus how many girls are musicians? 22. Plus how many girls on the stage crew was defined as x. And it was the total number of girls, 73. All right, so by solving this resulting equation for x, we will be able to determine the number of girls that are on stage crew and also actors. Okay, so let's combine like terms. 1 point, well, let's subtract 22 from both sides first. So subtract 22, and that gives you 1 point. Well, we can also add, just write it out so you don't get confused. 155x plus x equals 73 minus 22 as 51. Combine like terms, that gives us 2.55x equals 51. Now let's get x isolated, divide both sides by 2.55. And then you can do that with your calculator. And that will give you x is equal to 20. Okay, so x is equal to 20. Okay, so now I'm going to put the table right here so we can keep track of our work as we solve the puzzle. So X is the number of girls on stage. How do we know? Well, that's what we declared X as. Okay, stage crew is X. So we have that one figured out. So girls on stage crew is 20. Okay, but we can also figure out the number of actors, girls that are actors is simply 1.55x, but guess what? X is 20, so 1.55 times 20, multiply that with your calculator, you get 31. Okay, so this is 31, and this is 20. Okay, now, which row or column has two field, which row or column has just one missing element? That's the one we can figure out next, okay? So if you look at boys, we have two missing here, so we can do that one. If you look at the column for musicians, you have two missing, so we can't do this. If you look at the row for total, you have two missing, you can do that. But take a look at actors, though. You have two known and one unknown. See this right here? So that means we can figure out the total number of actors based on the fact that we have only one unknown on this row, in this column. Okay? So let's figure out that one out. So total actors, total number of actors is simply going to be the sum of male actors plus female actors, 31. You get 48. Bam, so this is 48. Now let's look for another row or column that has only one unknown. Total, just the grand total across each category right here. The sum of actors plus musicians plus crew, the grand total. This row can be used to calculate the total number of musicians. Okay, so total number of musicians is simply going to be the grand total, which is 126, minus the sum of the other two, actors and stage crew. Okay, so actors is 48 plus stage crew total, which is 43. Do this in your calculator, you get 35. So let's see, this is 35. Okay, now let's find another row or column with just one missing component. And as musicians, because we have only one missing one here, we can't do this because there are two missing ones. If we go look at the row for boys. So let's look at the column for musicians. We have the total, we have girls. So if we subtract the girls from the total, we should get the total number of boy or male musicians. Okay, so it's boy musicians is simply the total number of musicians, 35, minus the musicians that are girls, which is 22. Carry out this, if you subtract, you get 13. And now we can figure out the last missing piece, which is the number of boys that are on the stage crew. Just by subtracting actors and musicians from the total, boys, that will give us the total number of boys that are on stage crew. Okay, so boys on stage crew is the total, which is 53, minus the boys that are actors plus the boys that are musicians. Do that in your calculator, you end up with 23. And that's the total number of boys on the stage crew. Okay, so for this one, all you just do is you just click on the box you want to enter the result in, and then just type in your numerical value. Click on this, 23. Click on that, 31. Click on that, 20. So this is basically how you enter your answers on a question of this format. All right, so just type in your numerical values in the missing boxes, And that's that for question number 18. All right, let's take a look at question 19, the last in this review installment. It says Chantel drew a picture of her dog on a piece of paper that is 12 centimeters long. She uses a copy machine to enlarge her drawing. She used the 115% setting to make each new copy. She then used each new copy to generate the next copy. Using the same copy setting, enter a recursive formula that will give the length of each new copy. Okay, so for this problem, we really have to understand what this 115% setting means on a new copier. Okay, so you just have to note the following. Note that 115% means a 15% increase of the original. Okay, of the original. That's a photocopier language. Okay, when they say 100%, it means it's exactly the same size. But 115% means it's going to be 15% bigger than the original. All right, so how can we generate our sequence? Well, what we're going to do is start by writing down the formula for percent increase. So the formula is as follows. So if you want to increase a certain measure by a percent, increase by a certain percentage value, all you simply do is you multiply 1 plus the percent increase over 100, which can be expressed in decimal form. You multiply this by the original amount or measure. All right, so that's the formula we're going to be using. So what we're going to do is we want to calculate A1. Actually, we have A1. A1 is, what was A1? 12 centimeters, okay? So what will A2 be? A2 is going to be 1 plus the percent increase, which is 15 over 100, times A1, which is 12. But let's just leave it as A1, okay? Because we're trying to generate a recursive definition here. If I simplify this, this becomes 1 plus 15 over 100 in decimal form is 0.15. You can verify that with your calculator. So you have 15 divided by 100. It's just moving the decimal places to the decimal points 2 places to the left. Okay, so 0.15 is 15% in decimal format. Okay, so times A1. All right. Keep on going. So A2 is basically 1.15 multiplied by A1. Okay, so let's generalize. For AN, what will it be? For AN, it's going to be 1.15% increase. What's the relationship between A1 and A2? A1 comes before A2. So what comes before AN? Using recursive definition, AN minus 1. 2 minus 1 is 1. So AN minus 1 will give you the term that's before it. All right, so this is the recursive definition. So basically, we need the initial condition and the explicit formula. So we have this as the initial, and then the explicit formula, AN is 1.15 times AN. Actually, it's a recursive formula. So there goes your recursive formula for the whole situation. Okay, so let's just write down what they are. So this is the initial condition. That's what you start with. And this equation right here is the recursive relation. Together, they form your recursive formula for generating terms of this sequence that basically increases the size of paper by 15% over and over and over again. All right, so you might wonder, how on earth are we going to enter that crazy formula into the computer? Well, it's not that complicated. So A1 is the initial condition, which is 12. But A2 is complicated, right? So A2 is 1.15 multiplied by AN minus 1. So just hit A, and then you want to activate the subscript field. So you just click on this right here, the big box and the little box, so that activates the subscript field, and then you enter N minus 1, like that, and there goes your answer for question number 19. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for your upcoming Algebra 1 EOC exam, you give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe for the remainder of this review series. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.